Hi, everybody. This will be our review for tomorrow's 2.1 to 2.3 test. Questions 1 through 3 say graph each function below on a separate sheet of paper, then determine the following: domain, range, equation for the axis of symmetry, y-intercept, number of roots, and describe the transformation of the parent function based on the vertex. So we'll treat this as kind of a checklist once we have our graph, but the priority first is to get that graph. So all three of these will be on graph paper, and I have attached a piece to this worksheet for you to use. So let's move over to our graph paper. Our first graph will be for the equation y equals x squared minus 10x plus 25. Step back for a second and think big picture. What are we being given? What form is this in? This is standard form. So as soon as I know that I have standard form, recall that for standard form, we're going to use that little equation xv equals negative b divided by 2a. That will get us the x value of the vertex. So here, a in front, the coefficient of x squared is an invisible 1, b is negative 10, and c is positive 25. Let's do the math. xv equals negative 10 divided by 2 times 1 is 10 divided by 2, which is 5. So we have the x value of the vertex, but now we need the y value. So to do that, we will actually substitute 5 back in for x. So that would be 5 squared minus 10 times 5 plus 25. Pause here, please, and go ahead and use your calculator to do that, or mental math, whichever. But pause and get your answer, please. I got 0. 5 squared is 25, minus 10 times 5 is minus 50. So 25 minus 50 is negative 25, plus 25 is 0. So the vertex is 5, 0. Now that I have my vertex, I can set up my table. So x, y, and we want to situate the vertex right dead center in the middle. 5, 0 will be right in the middle. We're going to count back to, so 5, 4, 3, so 3, 4, 5, 6, 7. Remember that parabolas are symmetric, so I only actually have to do 2 calculations to fill out this whole table. So you could choose to do f of 3 and f of 4, or f of 6 and f of 7. That's all we need to take care of. I'm going to choose to work with f of 3 and f of 4. We'll be substituting into this equation. So f of 3 equals 3 squared minus 10 times 3 plus 25. Again, we can type that right into our graphing calculators to get that. Pause and get your calculation. I got 4. And then ask yourself, where does 4 go in the table? It will go here, because that we plugged in 3, we got 4. But remember the symmetrical nature, 3 is 2 away from 5, and so is 7. So 7 also has an output of 4. Next, we'll evaluate f of 4. So that would be 4 squared minus 10 times 4 plus 25. Pause and get your answer, and we'll compare. I get 1. So f of 4 equals 1, and so does 6, because both of these values are 1 away from the vertex. Now that I have my table of values, now I can graph. So make sure we're working with a straight edge to make it nice and neat. My vertex is at 5, 0, 1, 2, 3, 4, 5. And then let's finish graphing all of those points. So go ahead and pause, you finish graphing and I'll graph, and then we'll compare. So graphing my other points, 4, 1, 1, 2, 3, 4, up 1. 6, 1 would be right here, symmetrical. Notice how they're kind of like a mirror image of each other. 3, 1, 2, 3, up 1, 2, 3, 4. And then 7, 1, 2, 3, 4, 5, 6, 7, up 4. There we go. We've successfully graphed. Now we have that checklist of characteristics to talk about. So the list was domain, range, axis of symmetry, roots, y-intercept, and then shifts. My domain is negative infinity to infinity. My range, when I come in from the bottom, I hit 0, and that keeps going up forever and ever, so infinity. Pause here and work on these 4 by yourself, and then we'll compare answers. My axis of symmetry will be x equals 5. It's the x value of the vertex, right? Because here's my vertex at 5, 0, and I know that axis of symmetry is that vertical line that cuts right down the middle. So it would have an equation of x equals 5. Roots, I have one x-intercept, so there's one root. In my y-intercept, I can pull right from my c value. Remember, when we have standard form, c is the y-intercept. Any other form, and I would actually have to calculate f of 0. I'd have to plug in 0. But when I have standard form, I get it right from the c value. And then shifts, when I look at the vertex 5, 0, that means that it was shifted right 5, and then no vertical shift. I check a equals 1, so it's normal. It's not any wider or any narrower than normal. So if you want to mention a equals 1 normal, you can, but I would be fine with right 5 and then no vertical shift. Awesome. We're done with number 1. Number 2, says y equals negative 3 times x minus 1 all squared minus 4. Again, take a step back. What do we have? What are we starting with? Well, this is vertex form. And because it's vertex form, right away I know the vertex will be h, k. So ask yourself, what's h, what's k? Well, here's h, here's k. So right away I know that the vertex is 1, negative 4. Remember that this is originally x minus h. So x minus 1 means that h is a positive 1. If I saw x plus 1, I know that a negative 1 was plugged in right there, so then this would be negative. Remember that. That's our prior knowledge of the original form and how to pull out h correctly. So the fact that I have the vertex, that's nice, because I don't actually have to calculate it. Up here, I had to do work to calculate it when you start with standard form. But vertex form, I get it right away. So straight away, we can set up our table, x, y. Make that a better line. Where does the vertex go in the table? The vertex is going to go right in the middle. So 1, negative 4. And then no different, just like we did last time, count back. So 1, 0, negative 1, and then count forwards, 1, 2, 3. So 2 points above, 2 points below. When I look at this vertically, on the graph, it'll be 2 points to the left of the vertex and 2 points to the right. I'm going to choose to calculate f of negative 1 and f of 0. Looks like it'll be nicer math. But you could calculate f of 2 and f of 3. That would work fine too. So f of negative 1 would be negative 3 times negative 1 minus 1 all squared minus 4. Go ahead and use your calculator, figure out what that is, or mental math, your choice, but pause and get the answer on your own. I got, for this, negative 16. So the reason you saw me counting boxes, I don't know if you noticed that I was doing that, was because I now know that I'm going to have to graph negative 1, negative 16. So for my graph paper at least, I'm not sure where you are space-wise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, oh no. So what Ms. J is going to do is shift this up. So it's either whatever you need to do to fit it, make that happen. This is kind of annoying, but oh well. I'm going to move it all over. My smartboard marker writes quite a bit fatter than yours, so you're probably fine on space, but I'm going to shift over so I have room. So while I move all of this over, go ahead and calculate f of 0 to finish filling out your table. When I did f of 0, I got negative 7. So this is negative 7, negative 7. And we're ready to graph. All right, let's see if we can make this happen. So negative 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh no, I'm short 1 box. All right, I'll move this up. Okay, now I should be good. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yay, 16. Negative 1, negative 16 is right there. 0, negative 7. So 0 means you don't go left or right. You just go down 1, 2, 3, 4, 5, 6, 7. That's nice because I know I'm going to be asked for my y-intercept, so it's nice that we don't have any work to do. It's one of the points I found actually already. 1, 2, 3, 4. 1, negative 4. 2, negative 7. 1, 2, 3, 4, 5, 6, 7. And then 3, down 16. Okay, we got our graph. Let's get our checklist going. Domain, range, axis of symmetry, roots, and y-intercept. Go ahead and pause here. Oh, and shifts. Please pause here and fill this checklist out yourself, and then we'll compare our answers. My domain, when I come in from the left, I hit an arrow, come in from the right, arrow. So I know my domain is negative infinity to infinity, or all real numbers, however you like to write it. My range, I come in from the bottom, I hit arrows, so negative infinity, but I definitely have a restriction when I come in from the top. My largest possible y value is at -4. So -4 with a bracket. Axis of symmetry, remember, is that invisible vertical line that cuts right down the middle, all the way down. Its equation is the x value of the vertex. So that would be x equals 1. Axis of symmetry, x equals 1. Roots, we have none. So this graph is shifted down and is opening down. It will never cross the x-axis. None. Y-intercept was really nice. It was actually part of our points that was given. It's at -7. And my shifts, based on the vertex, so the vertex was 1, -4. So that was right 1, down 4. Here, what's A? A is -3. What does that mean? When A is greater than 1, remember the absolute value of A is greater than 1, that is more narrow, or a vertical stretch, however you want to say it, more narrow. If A was a fraction, just to give you an example, if A was 1/3, that would be more wide, and the graph would come out more wide. But notice, this one is definitely more narrow. So when A is not 1, you do need to come back and say more narrow or more wide. Fantastic. Let's go and do number 3. Number 3 says y equals -2 times x minus 3 times x plus 1. What form are we starting with? What is this? This is intercepts. So because it's intercept, I know I'm being given my intercepts. Here's P, here's Q. How are we going to find the vertex? So my given information, let's just get that down. So my x-intercepts are at 3 and -1. So that's nice. We'll use that in a little bit. But how about the vertex? Remember, for intercept form, we find the average of P and Q. So P plus Q divided by 2. So here that will be P, which is 3, plus Q, which is -1, all divided by 2. That's 2 divided by 2 equals 1. So the x value of the vertex is 1. To find yv, we're going to plug in. So -2 times 1 minus 3 times 1 plus 1. Mental math or your calculator, your choice. Please find that. We should get 8. So I know the vertex is 1, 8. Intercept form is the only form where I do not need a table from you. I am totally okay, I'm 100% okay with you graphing the vertex and your intercepts and calling it a day. So let's get this graph down. My intercepts are at 3, 1, 2, 3, and -1. And my vertex is at 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 8. and we have our graph. Let's get our checklist of characteristics. So domain, range, axis of symmetry, roots, y-intercept, and shifts. Pause it. Go ahead and work on this checklist yourself. Domain is all real numbers. Range, negative infinity to 8 with a bracket. Axis of symmetry, x equals 1. Roots, we have 2 of them at negative 1 and 3. My y-intercept, do we know it from the graph? Kind of be a rough estimate. I mean, this was a super rough sketch, so maybe it was supposed to cross here, I'm not sure. So to calculate the y-intercept, we'll calculate f of 0, plug in 0 for x. So that would be negative 2 times 0 minus 3 times 0 plus 1. So real quick mental math, that's negative 2 times negative 3 times 1, which is 6. So the y-intercept is at 6. When I look at my graph, 1, 2, 3, 4, 5, 6. So again, emphasizing a sketch, technically my graph should have come like that. Right? But hey, that's what makes this a sketch. And why you have to calculate. Don't assume. Because based on how I drew mine, that kind of looked like 7. But really, the intercept is at 6. All right, shifts. The vertex was 1, 8. What does that mean? That means right 1, up 8. Check A. What's A here? A is negative 2. So that would be opens down. I think I forgot to mention that on the other one. Opens down and more narrow. When you're done writing that down, I think number 2, I was supposed to say opens down. Yep. Number 2, if we go back and look at number 2, more narrow and opens down. If you wrote that and I didn't, you'd be like, oh, Miss J, see, I knew it. You're right. So if A is negative, make sure you mention that that causes it to open down. And then number 3 is all done. Let's get into factoring with number 4. Back on our worksheet. We're done with the graph paper. Factoring quadratics. Okay, so for number 4, I have a binomial, meaning 2 terms. So the best I can do is look for a GCF, or difference of 2 perfect squares. So here, neither of these are perfect squares. Right away, I know I'm going to look for a GCF. 6 and 20, I can factor out 2. Here, b squared and b, I can factor out a single b. That leaves 3b minus 10. And I'm done, as far as I can go. To know what I wrote on the inside, when I factored out 2b, ask yourself, 2 times what is 6? 3. There were 2 b's. You factored out 1. That leaves 1 behind. 2 times what is a negative 20? Minus 10. There was a single b. You factored it out. No b's left right there. When in doubt, you should be able to multiply back in, distribute this back in, and end up with where you started. Number 5, A is 1. So right away I know I will look for factors of C. Factors of C that add to B, because A is 1. So for negative 10, I first think of 5 and 2. C is negative, so one of these has to be negative, which is in my favor, because I need the 2 to be negative, so that when I add these, I get 5 minus 2 is 3. So x plus 5, x minus 2, and I'm done. Number 6, 5x squared plus 10x plus 5. The very first thing when I see a is not 1, I think, GCF? Maybe? Let's see. 5, 10, and 5. What can you factor out? I hope everybody is saying 5, because you're right. I can factor out a 5. Factoring out a 5 leaves x squared plus 2x plus 1. And now I'll just pay attention to inside. On the inside, I now have a quadratic where a is 1. So what are factors of 1 that add to 2? Well, the only factors of 1 are 1 times 1. It's in my favor that this is a positive 1, so both positive or both negative. To get a positive 2, I need 2 positive 1s. So this is 5 times x plus 1 times x plus 1, which you could write as a completely simplified answer, 5 times x plus 1 all squared. Number 7, 6x squared minus 13x plus 2. Oh man, there is no GCF because 6 is even, 2 is even, but look at 13. You can't factor out a 2 from that. So still not too bad though. I mean, this is not that big. So I would say guess and check inner, outer equals middle. What I mean by that is, so factors of 6x, I'm going to try 6 and 1 first. So I'll set up 6x, x, because 6x times x is 6x squared. Now factors of 2. This is nice. It's nice and small. I mean, my only options are 1 and 2. Where do we want to try 1? Where do we want to try 2? If you're not using a pencil, get a pencil, because for guess and check to work, we have to be able to erase. So what I mean by guess and check inner, outer equals middle. So here's my outer. That would be 6x. Inner, 2x. Now I see that this is positive. So both of these have to be positive or both have to be negative. So the only thing I could get out of this is an 8x or a negative 8x. So this does not work. So this is guess and check, which means maybe we have to switch these around. So maybe instead of 2 there and 1 here, I try 1 and 2. Let's try again. Outer, this is looking more promising. Outer is 12x, 6x times 2 is 12x. Inner is 1x, and I'm trying to get a negative 13x. That can happen if these are both negative. Is that okay? Yes, because these need to both be positive or both be negative. So to get a negative 13x, these will both be negative. My final answer, 6x minus 1, x minus 2. If that hadn't worked, I do have other factors of 6. I could have tried 3 and 2. So keep that in mind if this may have more than just one set of factors. Very nice. Number 8, 2x squared minus 50. As always, first thing, check for a GCF. Do we have one? Yes, these are both even. I can factor out a 2. That leaves x squared minus 25. Are we done? No. Why not? Because right here I have the difference of 2 perfect squares. 1, which is the invisible 1 right here. 1 is a perfect square. The square root of 1 is 1. And here, 25. That's a perfect square. And its difference, subtraction. You're subtracting. So difference of 2 perfect squares. 1 and 25 being the perfect squares we're talking about. Square root of 25 is 5. So this becomes 2 times x plus 5, x minus 5, and we're done. Number 9, 4w squared minus 5w minus 21. You could guess and check. If you are an awesome guesser, checker person, go ahead and use guess and check on this. Press pause and work it out. If we're like, oof, 4, that could be 4 and 1, that could be 2 and 2. 21, that's got 7 and 3. We're looking at some bigger numbers, so maybe I choose to use the diamond method for this one. So I'll set up my diamond over here. A times B goes up here. That would be negative 84. And, I'm sorry, A times C. I hope I said A times C. A times C, 4 times negative 21, goes up here. B goes down here. So your job is to find factors of negative 84 that add to negative 5. So pause here and find those factors. 2 numbers that multiply to a negative 84 and add to a negative 5. I get 12 and 7 multiplied to 84. To get a negative 5, if the 12 is negative, I'm in good shape. Negative 12 plus 7 equals negative 5. Remember that we're using these two numbers to rewrite this middle term. So we can now rewrite this as 4w squared. I'm going to try keeping this order. So negative 12w plus 7w minus 21. I pulled these two numbers and I rewrote my negative 5w as negative 12w plus 7w. Remember that we're going to put this dashed line right down the middle, keeping this sign with the right side. What GCF do we have right here? Well, 4 goes into itself and 4 goes into 12, so I can factor out 4. W squared here and a w, I can factor out a w. What's left? W. We factored out the 4. There were 2 w's. I took 1 out. That leaves 1. 4 times what is negative 12? Minus 3. And there was 1. I took out 1, so none left right there. Positive 7w minus 21. I can factor out a positive 7. That leaves w. 7 times what is negative 21? Negative 3. And check out what we've got. We are in good shape because I see w minus 3, w minus 3. So factor by grouping, if you were to factor out the w minus 3, that leaves 4w plus 7 behind, and we're done. Number 10, real-world vertex question. The path of a large stone thrown from a catapult can be modeled by, and I have this function, so it's nice that it gives me the function. And check it out, it defines my variables. X is the distance the stone traveled in yards, and y is the height of the stone in yards. A asks me to define my variables. No work there. It told me X equals distance stone traveled and that's measured in yards. And then y equals height of stone, also in yards. Find the maximum height. The reason why I right away knew that this was a vertex question when I saw maximum is because think about what this sketch looks like. Does this parabola open up or down? Well, I see A is negative, so I know that this opens down. So this is the path of the stone. I really shouldn't have an arrow on the left. Here's the path of the stone. Where is the maximum height on this graph? Right here. And what point, there's the max. What point on the graph is that? That's my vertex. So when I calculate the vertex, I'm finding the height. So let's calculate the vertex. Another thing, by the way, that can help you, if you were to visualize this on an XY plane, X is distance, so get some labels. Here's distance, here's height. I'm asked for the maximum height, so I know that I'm actually looking for the Y value of the vertex, but to get the Y value, what do you have to find first? Can't find Y without X. So let's first find the X value of the vertex. Negative B divided by 2A will be negative 1.145 divided by 2 times negative 0.00545. Purely a calculator exercise. Make sure that in your calculators you group this multiplication together with parentheses. Otherwise it'll come out wrong. So in your calculators, type in negative 1.145, divide by, and then in parentheses, put your 2 times negative 0.00545. we should get 105. So this is 105 yards, but this is distance, this is not height. However, we needed to do this so that now we can actually find our height. We're going to do that by calculating f of 105. So wherever we see x, we are going to be substituting in 105. You can do that all in one step in your calculator, carefully using parentheses. Don't forget the square. Go ahead and pause. We'll compare answers. I get 46 yards. And this is for the height. So, maximum height of the stone. Max height is 46 yards. I was going to abbreviate, but the fact that I forgot the A drives me nuts. So, I will write it out. Abbreviating is perfectly fine. Okay. Find the distance the stone traveled. Find the distance the stone traveled. And we have a hint here. Find the hint. Think about where the vertex is located in relation to the x-intercept. So let's bring our sketch back over here, okay? And then I've got the path of the stone. I know that the vertex is what ordered pair? What x comma y do we have here? Well, here's x, and here's y. So this is 105 times, 105 comma 46. So the height was 46. If you were to kind of mentally drop this down, drop, this is 105. So there's a strategy to this question that we can actually be done very quick. Think about what this means for this to be the vertex. This is exactly the halfway mark, right? If you were to fold this in half, it would be right on top of each other. It's symmetrical. So here's xv. If I double my vertex, 105 times 2, what does that equal? 210. This is at 210 yards. So, stone traveled a total distance of 210 yards. That is the strategic approach to this question. Now, if you're like, I don't like that, I like more of an algebraic approach, I will show you how to do that right here. If you're someone who sees this, that this is halfway, so I can just double the x value of the vertex to find this, go ahead and jump forward a couple seconds. For all of my algebra people out there, what we are going to do right now is look at our original function, which was f of x equals negative 0.00545 x squared plus 1.145x. Okay, so when is the stone done traveling? Well, the stone is done traveling once it's hit the ground, and the ground is 0. That says ground, believe it or not. 0 is ground. To figure out algebraically, we would set this equal to 0, because we're saying, when does the stone hit the ground? So set it equal to 0, because 0 is ground. 545x squared plus 1.145x. Okay. We can factor out a GCF. What's the GCF? Negative. I'll factor out a negative. I see two x's here, one right there. So I'll factor out negative x. That will leave behind 0.00545x plus 1.145. And this is still set equal to 0. I now have two factors. Here's one. And here's one. So we can now take each of these factors, set them equal to 0, and solve. So what that will look like, our two little equations will be negative x equals 0 and 0.00545x plus 1.145 equals 0. Solving this for 0, divide by negative 1, divide by negative 1, x equals 0, which is right there. It's at a height of 0 when it hasn't launched off the ground yet. And then if you solve this one for x, you will get x equals 210. In that order, that pair, x equals 210, bam, right there. And I'll let you work on that algebra. Subtract 1.145 from both sides, divide by that awesomely huge decimal, and you will get 210. On the test, I would fully accept this reasoning. Show me the sketch so that you understand that the x value of the vertex is halfway, double it, and you have your answer. Or be algebra awesome and show me the algebra, your choice. Moving on to number 11. Determine whether each quadratic function contains an absolute minimum or an absolute maximum, and explain why in one complete sentence. Notice it says you do not have to find the vertex, and let's reason on why. Just from looking at A. So for example, here, what's A? A is negative 1/2. I don't even care about the 1/2. I care about this negative. What does that negative tell you? Negative tells you the graph opens down. So if it opens down, is this a max or a min? It's a max. So opens down. I know I have a maximum. Your complete sentence would be A is negative, so I know the graph opens down, therefore it has a maximum. Take a look at B. The fact that this is positive, A is 2. Because A is positive, I know the graph opens, how? Opens up. So sketch something that opens up. Ask yourself, would this be a max or a min? This is a min. Again, your complete sentence, A is positive, I know the graph opens up, therefore the graph has a minimum, and you're done. So notice this was purely an observation of the effect of A and a quick sketch. No calculations whatsoever. Awesome. Number 12, identify any obvious key characteristics in each quadratic function below. So again, no math, just characteristics. Let's take a look at A. It would be awesome if you pause and actually try this on your own. What characteristics can you find? And then we can compare. So I know that A equals 1. From that, I know it's a normal width and opens up. I also know that C is 18, so my y-intercept is at 0, 18. That's as much as I can do without doing math. I can look at A and tell if it's normal, wide, or narrow, how it opens, and then my C value is my y-intercept when I have standard form. Pause here, try B on your own. What can you get from B? The graph for B is in intercept form. I know that A equals -2, What does that tell us? Well, the absolute value of this, which is 2, is definitely bigger than 1. So this is narrow, more narrow. A is negative, so it opens down. And I have intercept form, so what are my intercepts? I know my intercepts. My x-intercepts are negative 11 and a positive 3. That's as much as we can say without doing math. Go ahead and pause. What can we get from C? For C, this is vertex form. I have an A value invisible right here. A equals 1. So from that, I know that it's normal width and opens up. What kind of form is this again? It is vertex. So I know the vertex. What's the vertex? The vertex is negative 6, negative 2. Remember, I have this originally had x minus h. So the fact that I see a plus 6 means a negative was plugged in. So I know the shifts. Shift left 6, down 2. Because you know how this opens and you know the intercepts, let's do a quick rough sketch. So my vertex, left 6, down 2, and I know that this opens up. How many roots do you have? How many roots? 2. 2 roots. So we get a lot from here. Very cool. 13, determine which functions could be represented by the given graph. Explain why or why not in one sentence. So take a look at the graph. Here, I have a positive A. And I know the vertex is 75, negative 92. So if I were to do a rough sketch, -75, negative 92 is somewhere down here, and it opens up. That's a bad graph. Let me fix that. There we go. Something like that. So this could be one. That's possible. How about this one? I know I have a positive A value, so it opens up. My roots are x equals 8 and x equals negative 2. So if I draw the sketch for that one, oops. X equals 8. Ooh, right away I know this is no good. Why? Because here, both x-intercepts are what? Positive. And here, one of them is negative. That can't be. I can't have a negative intercept. So this is a no. Second one is a no. Third one. 8x squared minus 88x plus 240. I can calculate the vertex. I know it opens up. Positive A. Opens up. Calculating the vertex for this one would be negative B, so negative 88 divided by 2 times 8. That's 88 divided by 16, which is 5.5. All right, we're still in good shape. 5.5 is to the right, so we got to figure out f of 5.5. Go ahead and use your calculator to figure out 8 times 5.5 squared minus 88 times 5 plus 240. That gets me a negative 2. Did you get negative 2? I hope so. So putting this together, the vertex is 5.5 comma negative 2. So what would that graph look like? 5.5 to the right and then down, and it opens up. Could this work? Rough sketch? Yeah. Yep, this one's possible. Now you might be saying, well, doesn't this one look like this one? And I know I'm doing a very rough sketch. Technically, we don't know anything about the x-intercepts, so this could be more like that. We just don't know. So the location of the vertex and the fact that it opens up is as much as we know, and it could be the graph. So yes. How about this one? Well, I see that A is negative, opens down. Right away, no, because this one opens up. So no, don't even have to sketch anything for that one. How about this one? A equals 2, so A is positive, positive A, opens up, and that's good. Where's the vertex? Vertex is negative 4, negative 2. Right away, I know no, because the vertex is this way, negative 4 down 2. So the vertex is in the wrong spot. If you were to sketch that, negative 4, negative 2 is somewhere over here, opening up. So, no. Last but not least, x squared plus 6x minus 2. Well, A is positive, so I know this opens up. That's a good start. Positive A opens up. Let's see what the x value of the vertex is. xv equals negative 6 divided by 2a, which would be 2 times 1. That's negative 6 divided by 2. Right away, I know no, for the same reason that this was no. My x value of the vertex is shifting left 3, which is no good. Let's talk about 14, transformations. If you don't have colored highlighters, let's get some colored highlighters out. Given the graph of P of x and M of x, so I will choose to make P of x green and M of x is going to be blue. Here's P of x and M of x. Oops, too thick. Okay, so given these two graphs, answer the following questions. A says if f of x equals x squared. Well, I don't have f of x equals x squared on my graph. I don't have these at all. So let's draw it real quick. I know that f of x equals x squared is my parent function. So intercept at 0, 0. Okay, so I drew in my own f of x equals x squared. Now we're in good shape to start comparing. That one is yellow. Write an equation for P of x, my green one, in terms of f of x. So notice I'm completely ignoring blue. Who cares about M of x right now? We just care about how do I write P of x starting at f of x equals x squared. Well, let's see what's happened. How do you get from here to here? What happened? Well, I had a shift get this vertex right here, there was a shift left. How many? 2? Still opening up, that didn't change. No other vertical shift of any kind. So P of X equals no change to A, just F of X minus, minus 2? No, plus 2, because we're shifting left. And we're done. If there was any kind of vertical shift, maybe I'd have like a plus or a minus here, but notice it was just shifted left 2 and then nothing else happened. So we're done right there. B says if f of x equals x squared, write an equation for m of x, which is my blue function, in terms of f of x. So now we're going to ignore green. Who cares about p of x? Nobody. Look at the blue graph. So again, my starting point, where I start from, is purple, my purple x squared. How did the vertex get from here to over here? So that was a shift right. 1, 2, 3, 4, 5. So let's write that down. Shift right 5. But then that's not it though. Not just a shift right 5, also up 1. So m of x equals, no flipping happened, it's not opening down, f of x minus 5, that's a shift right 5, close it, plus 1. I had a vertical shift of a positive 1, and we're done. C says, write an equation for p of x, which is green for me. I'm going to highlight that green, in terms of m of x, my blue graph. So now the question is, ignore the purple, right? You see no mention of x squared here. How did we go from here to here? So that was a shift right. 1, 2, 3, 4, 5, 6, 7. Right 7, shift right 7. And then up 1. So it's going to look a lot like this one. Write an equation for p of x. So p of x equals, take m, shift it right 7, up 1, and we're done. D says, write an equation for m of x, which is blue for me, in terms of p of x, which is green. So now instead of looking here and getting here, we're starting here and making our way this way to this green graph. So starting at this one, I go left 1, 2, 3, 4, 5, 6, 7, shift left 7, left 7 got me here, and now down 1. So write an equation for m of x. Starting here, m of x equals, take the graph for p, shift it left 7, so x minus or x plus. Left would be plus. X plus 7, down 1 is a minus 1, and we're done. All right, last but not least, sketch the graph of g of x equals negative p times x plus 5. So in words, write down what your transformations are. X plus 5, that tells me a shift left 5, because again, there's a negative 5 that got plugged in there, and it's now going to open down, a reflection over the x-axis. Notice the starting function. We are making a change on p. See, p right there? So that's how I know where to start. So looking at the green graph, left 5, 1, 2, 3, 4, 5, puts me right there. No vertical shift of any kind, right? You don't see any plus or minus. And now make it open down because I have a negative a value. So there's my new sketch. I'll make that pink. It's a very intense pink. But here's G. Here's the new function. So this has been shifted left 5. Oh, I didn't want a straight line. It's been shifted left 5 and is now opening down, and we're done. This is G of X. And we have completed the review. So any questions, please send me a remind. I will be checking throughout the night for any questions that you have. Be ready for all things graphing, factoring, real-world vertex, and translations, transformations. Have a great day, everybody.